I think we are live. So can you guys just let me know in the comments if you guys can hear me properly? Uh, just let me know if you guys can hear me properly. Please let me know in the chat if you guys can hear me. Or actually, I can verify myself as well. Let me know in the chat if you guys can hear me. Okay, I think I'm audible. So hey everyone, and today we'll be discussing the problem for the day for yesterday. And the problem name basically is exactly one swap, right? So I'm pretty sure that many of you must have already solved this. It's pretty simple problem. I don't know why it is tagged as medium. It's a pretty simple problem, but again, we'll try to solve this. If you weren't able to solve, we'll try to solve this today. So first of all, let's start with the problem statement. So the problem statement is you are given a string S that contains only lowercase English alphabet characters. Okay, so you're given a string S that only contains lowercase characters, lowercase English alphabet characters, right? So the task is to calculate the number of distinct strings that can be obtained after performing exactly one swap. So how many distinct strings can you generate after performing exactly one swap, right? So you have to perform exactly one swap, and what is the number of distinct strings that you can generate? In one swap, geek can pick two distinct indices I and j, that is I less than j less than s of the string, then swap the characters at the position I and j. So after in a swap, it can the person who is swapping, he can take the string, he can take two distinct indices I and j, and he can swap the characters in those two indices, right? Let's see if we also face similar issues. Let's see. Okay, so you are given the string geek, and the output will be 6. Why is the output 6? So what we the question basically tells you, hey, you're given a string, you can swap any two characters, right? Any two characters, but the characters must be in different places. Like you cannot swap a character with its with itself, like or swap a index with itself. You take two indices, you swap those characters, right? You do like this. After exactly one swap, what are the possible strings that you can generate? Out of them, you have to only tell how many distinct strings you can generate. Okay, so let's understand with this example. So geek is there. Geek, if we swap, how many swaps we can do? Ge we can swap. What do we get? Egeek, right? Then we can swap this E and G, this second E and G, we get EEGK. That is one way. After that, we can swap these two E together, or we can swap K and G as well. So it will be KEEG, which is this one. After that, we can swap these two, and it will be geek again, right? We are performing one swap. It is not said that it cannot be equal to the original string again, right? It cannot be equal. It is not said. But how many distinct strings that we can generate after exactly one swap? That's what the question is. So GEEK will get one from here, E and this. After that, what we'll do? E and K we can swap. So GEKE will be one of them. So GEKE, where is GEK? GEKE. And also we can swap this E and this K. We get GKEE, which is this one. So basically we can generate 6 of them, right? We can generate 6 of them. Let's come to the second part is AB. So AB, you have to exactly do one swap, right? So only possible way is swapping them BA. So the only string that you can get is BA. You cannot do any more changes. So this is the question. Does anyone have any doubt with this? Anyone has any doubt with this? Is the question clear with everyone? Let me know in the chat if the question is clear with everyone. So you're given a string S, you have to swap do exactly one swap. In a single swap, you can take any two characters and you can swap them. You have to take two indices, you have to swap the characters at those indices. After performing exactly what one swap, what are the number of distinct strings that you can get or you can generate? Is the question clear with everyone? Let me know in the chat if the question is clear with everyone. Is the question clear? Let me know in the chat. Just write yes or no in the chat. Is the question clear? So basically, I'll just give examples here. So we can take an example. Let's say, what can we take? A, B, A, C, right? A, B, A, C. Or A, B, A, C, A. Let's do this. A, B, A, C, A, right? So one way can be, we can swap A and B. So it will become, one of the possibilities is B, A, C, A, right? Then we can swap these two A's. So we get the same one, A, B, A, C, A, right? After that we can swap again this one, but again, like if we swap these two, see, if we swap these two, it will again give A, B, A, C, A. But again, we have, first time we swapped these two, second time we have swapped these two, right? So but we are getting the same string, so we just want the number of distinct, right? So we will not take care of this. We have already got A, B, A, C, A once, will not take that again. So A, B, A, C, A, right? A, B, A, C, A. After that, here we can swap B and A again. So there are multiple ways, right? It can be A, B, C, A, or B and C can be, B and A can be swapped. So A, again, if B and A are swapped, what will it be? A. So this B, sorry, yes, this is done. This B and this, it will be swapped. If it is swapped, so it will be B, AACA, right? So like this, there will be multiple strings generated and we have to find the number of distinct ones, right? So here we actually saw a counter case, like one thing that you can understand from the question, like we'll now go to the solution definitely. So one thing that you can understand from the question is, if we have any two distinct, if we have two characters, right, A and B, if you have two characters A and B somewhere, you can definitely swap them, right? And it will give rise to any new character. Let's say there are three distinct characters A, B, C. You can always, or any three, like whatever their value is, you can always swap them, A, B, B, C, A, C, and you will get three distinct characters out, right? You will get three distinct strings out. So you can always swap like this. So the answer might seem to you that basically it's similar to choosing any two index, right? It might seem to you that the answer is NC2. NC2 is number of ways you can choose two indices, because we can see that if all the characters are distinct, if we just choose any two indices, we can basically swap them and generate a new string, generate a distinct string, right? We can always do that if the characters are all distinct. But as the characters are not distinct, so we cannot do NC2. Why not? Because we have already seen an example, the example that we have seen right now, which is A, B, C, A, right? Or let's take A, right? A. So in this, if we interchange these two, we get A. We interchange these two, we get A again. And we interchange these two, we again get A. So we want the distinct count, right? So all of them is reduced to 1. All of them is reduced to 1. A, because we want the number of distinct strings, right? They are not distinct, they are same. So the problem is only when we have some repetitive characters, right? Or we have the same character. Whenever we have same character, we see that we have to choose only one of them. we will get multiple of them, but we have to only choose one of them. And for distinct characters or for two different characters, we can always swap them. We can always swap two different characters, but for same characters we will only choose one of them, right? We will only get one string out of them basically. Okay, that's one observation. Another thing that you might think about here is, let's say, can we use 2D array to solve it? You cannot use a 2D array. If you see the space constraints that is given to you, the space constraint is order of 1, right, or a constant space, and the time complexity is order of s, that is the length of the string. So you have to solve it within order of 1 space and order of s, order of okay, reconnection. Okay, done. Cool. Okay, so one more. Okay, I think we are back. Okay, so one more thing that we have to tell here is, you might think that, hey, a, let's say we have two a's and we have a b. How many distinct strings we can get? We can actually swap all of them, right? We can swap these two together. Only these two is different, and we can swap these two again, and we can also swap these two. But again, like if there are multiple a's, then we'll take that case separately. We'll take care of this separately. But if there are if there are two same characters or more same characters and the different characters, we can perform all possible swaps. Like for all the same characters, we can swap them, and they will give different results, right? Like this one will give BAA, and another will give ABA, right? So these are the two distinct different strings that we are getting. So basically we see that we can swap any pair of elements. We can basically swap any pair of elements. The only constraint is when there are equal elements, right? When there are equal elements, we cannot swap all of them. Only one string comes out of all the equal characters. By swapping only the equal characters, only one string comes out of them, right? So this is the only constraint that we have to maintain. So let's look into the code. So before we jump into the code, how do we solve this? It's pretty simple actually. What we can do is we can maintain the count. We can maintain a hash map or something like that, or an array of size 26, and we can maintain the frequency of each character. So frequency of I is equals to number of times ith character occurs. So what is ith character? Ith character is basically, 0th character is A, first character is B, second character is C, third character is D, like that Z. All these characters are mapped down to the number 0 to 26. These characters will be mapped down to the number 0 to 26. Frequency of I will be the number of times the ith character is occurring, right? So the answer will be, for same characters, we'll first try to swap different characters, right? So answer plus equals to n minus whatever is the frequency of the character that we are at right now. So frequency of character we are at right now. So let's call it char, frequency of char, right? Answer plus equals to n minus frequency of char. That is basically what it is telling, all the characters that are not equal to the current character that we are at, right? So we are running a loop for all the characters. We are running a loop for all the characters in the string. For each character, we are checking how many characters are there that are not equals to this character. If any character, all the characters that are not equal to this character, we can swap with them, right? So answer plus equals to. But again, if you see, we will do some repetitive work here. So basically, we are swapping A, B, and we are again swapping B with A, right? When we are at B, we are again swapping with A. So we are basically counting everything 2 times. So we have to divide by 2. Answer by equals to 2 we have to do. And after that, we have to go for after that we can go for we can go into all the similar characters, right? So all the characters that are there, and we can do if frequency of character is greater than 2, if frequency of character is greater than equal to 2, then we can just do answer plus plus. Only one string will come out of them, right? So we can just do answer plus plus. For each element, then how n into n minus 1 by 2 are waste swap for repeated elements? There are n into n minus 1 swap for each element. How are there n into n minus 1 swap for each element? there is n swap for each element, n minus 1 swap for each element, right? Any element can be swapped with any one of the other elements. So basically, let's say we have a element A, right? And there are other elements out there. A can be swapped with each one of them. So there are n minus 1 swaps for each element. But if we have, let's say, 3 A's, right? If we have 3 A's, so A can be swapped with this, A can also be swapped with this, right? And this A can also be swapped with this. But what is the string that is generated? If you see whatever is here, whatever, like let's say some other things are there, you are exactly doing one swap, right? So A, after this swap, it becomes A something, A something, A something, right? After this swap with this swap, these two A's are swapped, this one and this one. You again get the same string out, right? So basically, if there are same character, you just get one string out of them by swapping these same characters, right? So that's why we have to just take care of that separately. So let's write the code for this. So int answer equals to 0, right? And we'll maintain a frequency array. So int frequency, and we'll create an array of size 26 because there are 26 distinct characters. And initially we can initialize everything to 0, right? So for, and we can go through all the characters one by one. So cad x belongs to s. So we are going through all the characters one by one. Now we'll increase the frequency of int of x minus a plus plus, x minus a plus plus. We are increasing the frequency of each of them. Now in the frequency, we have the frequency of all the characters, right? Now we will group each character with number of characters that are not equal to this character, and we can swap each of them, right? So for cad x, again, for cad x belongs to s, answer plus equals to, what is the number of characters? What is the, so n is the size, right? Let's define n here. Int n equals to s dot size. Okay, what is the number of characters in the string that is not equals to x? What is the number of characters in the string that is not equal to x? So number of characters equal to x is given by the frequency. So it will be total number of characters, that is n, minus frequency of x. So frequency of x minus a. So number of characters, but again we have done some repetitive calculations here because if a and b are two characters, for a we have already taken the count of b. For b again we are taking the count of a. So we have done some repetition. So we have to do answer divided by equals to 2. Now we will come to the distinct characters. So for cad x belongs to s, for each distinct character, what do we do? For each distinct character, what do we do? We see that for each distinct character, we can, if there are, let's say, 5 A's, right? We can generate, by swapping only among the A's, we can just generate one distinct string. So if frequency of x, okay, wait, something. Okay. If frequency of int x minus a, कुछ तो प्रॉब्लम हो रहा है. If frequency of int x minus a is greater than equal to 2, then we will do answer plus plus. We'll get one distinct string out of them, and we can finally return our answer. So this is the code, right? We can finally return the answer. So let's compile this. Let's see if this is working. Okay, our output is 7. Why is the output 7? Let's see quickly. So answer plus equals to n minus frequency of int x minus a, and we have done x minus a, right? So initially everything is 0. Yes, everything is 0, set to 0. After that, what we are doing, let's see. So count of g, let's just run our algorithm once. Let's just write on this and we'll figure this out. Let's say e into e minus 1 by 2 waste swaps. Yes, exactly. So if there are e repeated elements, right? If there are e repeated elements, and then e elements of frequency a, so there are e into e minus 1 by 2 waste swaps basically. E into e minus 1 by 2 minus 1, because one of the swaps will be a valid one, but the remaining will be invalid. Yes. So geek, right, let's take the example of geek. So geek, so frequency of G is 1, frequency of E is 2, frequency of K is 1. So when we go to what is size of n is 4. So for G we get n minus frequency of G, n minus frequency of G. Also, yeah, I think 3, I think that's valid. N minus frequency of G is 4 minus 1, that is 3, right? So that's there. Okay, that's there. So 3, in fact we can make 3 changes, like G can be coming here, G can be coming here, G can be coming here. So there are 3 possibilities for E. N minus, so 4 minus frequency of E is 2, that is equals to 2, 3 4 5. And I think G is coming to 3 places. E can do 2 swaps. Okay, E is computed again, right? Both the E's are computed again. But that's true, right? E can do two swaps. E can come here, E can come here. This E also can come here and it can come here. Both will be different, right? This E can come here. So what are we missing here? Okay, we are anyways doing recomputations, right? So E will be 2. For K it will be 4 3 again, right? 3 3 6 7 8 8 8 by 2 we got 4 swaps already. We got 4 swaps already. Now for E we have one more, so the answer should be 5. The answer is coming us to be 5 here. Let's see once again. 2 to 4. I think my made some calculations. 2 3 3 6 8 10. It will be 10. 10 by 2 will be equals to 5. 5 plus 1 should be equals to 6. Why is it coming to be 7? Right? Why is it coming to be 7? Let's see. So frequency, we have incremented the frequency. Then we are going through all the characters of S, and answer plus equals to n minus frequency. This. Let's print the answer here itself once to see if this is working. Good afternoon. So let's print our answer here once. See out answer slash n, right? See out answer slash n. I think it should give some wrong thing. Uh, it is giving us 10. 10 is okay, right? 10 is okay. So this is fine. And frequency of x minus a greater than 2. Oh, okay. We are not, we are, so what problem we have done here? This is wrong, right? We are going to E and we are already computing one for this E. Again, we are coming to the next E and we are again doing that same computation again. So instead of that, what we should have done instead is for int I equals to 0, we can just loop on the frequency array, right? I equals to 0, I less than 26, I plus plus, and if frequency of I is greater than 2. So we should go over all the distinct characters, right? We should go over only the distinct characters. So now we get 6 output. So I think this should work. So let's try to submit. Okay, it's not working. Lol. B D C E. 1 second. Let me see. Answer by equals to 2. Yes, 41. I got 41 here, and it should be 39. B D C E C A B C B C. Okay. Frequency of I greater than equal to 2, then answer plus plus. Yes. This should be right. VDCE. E swaps with E, then it gives a new word geek. Yes, exactly right. But again, like if you it gives the word geek, right? But again, like just assume there are 3 E's, right? Let's assume there are 3 E's. G E E geek. Okay. Now E swaps with E. This E swaps with this E. We get geek out of this. This E swaps with this E. So G again same thing. Again this E swaps with this E. So again we get the same thing. So if you see all of them, like only one of them is valid, only this is valid, all these are repeating again, right? We want the distinct strings out of it. So that's why we should just add one for all the repeated characters. We should just add one for them. Okay. Let's take this example BDCE. Sorry, clear canvas. BDCE VDCE C VDCEC VDCEC AABBC 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 AABBC, right? Okay, so what is the frequency of B? The frequency of B is 1, 2, 3. What is the frequency of D? D is 1. What is the frequency of C? C is 1, 2, 3. 3 again. What is the frequency of E? E is 1. A is 2, I believe, right? 2, 3. C, yes. C, D is 1, A is 2. Okay, so what is N? N is the total size. So 3 plus 1, 4, 5, 6, 7, 8, 8, 9, 10. 10. Okay, so for B, how many do we get? How many places we can swap with? 10 minus 3, 7 places, right? We can swap with any one of these 7 elements. Only swapping with B will make no sense. D can swap with 9 places, right? 10 minus 1, 9. C can swap with how many places? 10 minus 3, 7 places. Each C can swap with 7 places. 1 second. We should go for all the characters one by one, right? B is swapping with 7 places. D is swapping with 9 places. C is swapping with 7 places. E is swapping with 9 places. C is swapping with 7 places. 7 places are there, right, for swapping of C, and that will be different. All of them will give different. A is swapping with 8 places. A is again swapping with 8 places. B is swapping with 7 places. B is swapping with 7 places. C is swapping with 7 places. So what is the total? 7, 7, 14. Okay, we can remove some, we can all do by 2 directly, like 7, 7, 14. We see how many 7s are there. 1, 2, 3, 4, 5, 6. 6 7s are there, so let's just remove 3 of them. Because we'll be doing by 2, so let's just remove 3 of them. Okay, how many 8s are there? 1, 2. Let's remove 1 of them. How many 9s are there? 2, so let's remove 1 of them. So this should be the final call. So 7, 7, 14, 21, 30, 38. 38 is what we get out of this. 38. What was the answer again? Answer is 39. How can it be 39? How can it be 39? Any idea like what is going wrong there? What if we do like this, that whatever characters we have seen till now, any idea where it can go wrong? Where is it going wrong? What if we just do something like this, that we are going from left to right, and whatever characters we have seen till now, we are just pairing with those, right? So pairing with those, basically n minus that. Okay, let's do like that, if that works. But again, like, I think that would give the same answer for this. I'm not sure why is it not PDC PC. Okay, let's do like this, that anyone sees anything wrong with this? Like, where are we going wrong? Or we can go like, do like this as well. We are going from left to right, like we're going from left to right. So what we can do, before we do this, answer plus equals to, so number of characters that we have seen in num seen equals to 0, and num seen plus plus. So answer plus equals to num seen, number of characters we have seen, minus the same characters, x minus a, right? Num seen plus plus. So that will reduce this one. Okay, same characters. So yes, now frequency greater than 2, answer plus plus. But I think it will give the same thing for this one, because it is kind of logically right. Let's see. if there is a occurrence of one element more than once, then plus 1. So greater than equal to 2 is what I've done, right? Yeah, I'm still getting 41. I've done that. I've taken that, right? Anywhere I'm going wrong? Let me see. BDC. I don't think I'm going wrong anywhere. Okay, I think I understand where I'm going wrong. Let's see. Actually, I think I missed this, right? Let's take this example, right? Let's take this example only because I think this is a good example. What we have done here is, we are, just think about this, right? Let's swap these two. Let's swap these two. What will happen? BD, CE, C, A, B, B, C. Now, if we also swap these two, if we also swap these two, we also get the same thing, right? BD, C, C, A, B, B, C. So if there is any character that is repeating, if we swap them, every time we get the same string, that is the string that we started with. So only one string is there, right? So what we can do is, so only one string is there. So we should always, whenever we reach this, if one of them is repeating, then we can do answer plus plus and break, right? And if we run this now, this should work actually. 6 6. Let's submit. Okay, input is too large. Is it because of the answer long? Let's make everything long, right? Long, and num sim is also long, and it is also long. Yes. So it is passing finally. So this is how we can solve this. Basically, the mistake was that when there are multiple characters that are repeating, right? If we swap any two of them, we actually get the same string that we started with. So it's not that for every character the multiple occurrences are swapped, we can just have one distinct string. Rather, for every possible repeated character, if we swap them, we get the same string back. You are facing the runtime error probably because you are using an integer here. So you should use a long integer here instead of integer. A long integer actually, because the answer will be big, right? The answer will be big because it's somewhere around n into n minus 1 by 2. Somewhere around that. Not exactly that, but it's definitely around somewhere around like more than 10 to the power 9 plus more than 32-bit integers. So just take a long and it will work. So is this clear with everyone? How is this working? Is this clear with everyone? Okay, you are using long, still you are getting runtime. I'm not sure. You can send me the code in my LinkedIn, right? Just connect with me on LinkedIn. Send me your code. I'll definitely take a look, and I think we can figure it out together. Like what will happen, right? What's going wrong basically. So I think it's clear with everyone. So thank you for joining in. And Alok, do send me the code over LinkedIn. And if anyone else wants to send your code, do send me over LinkedIn, and I'll try to help you out there, right? So thank you guys for joining, and